Hello. Welcome to the demo of INCR, a new library for incremental computation. The objective is to develop an open-source, high-performance and general-purpose library written in C++ for building incremental programs. The library includes a runtime that keeps track of data dependencies and dependency graphs, caches sub-computations by memoization, and repairs outdated computations via change propagation. On top of the system runtime, the library also provides a collection of standard algorithms, including transform, filter, and accumulate, for writing clear, accurate and fast incremental programs. So, what is an incremental computation? A computation is said to be incremental if it can react to input changes by only recomputing outputs that depend on the changed inputs. As a result, incremental computations update their outputs more efficiently than from scratch recomputations. Moreover, incremental computations can be applied to many applications. For example, in a spreadsheet, when we change data or formulas, the software will only update charts and cells that depend on the changed data. Similarly, when we modify the source code of a project, the build system only recompiles files that have been affected by these changes. These computations are all incremental in nature, as they can all produce correct outputs when input data changes, without performing all computations from scratch again. Next, we are going to look at the architecture of the INCR library. Firstly, we have the runtime. The runtime has three modules. The dependency module is used to track data dependencies between computations. The change propagation module repairs the dependency graph when inputs are modified. And lastly, the memo module caches previous computations and results. The runtime is the foundation of the INCR library, and it provides developers with the core functions to write incremental programs. Developers can access these functions by calling user-facing application programming interfaces. On top of the runtime, we have a collection of standard algorithms that are frequently used in incremental programs. Firstly, the transform algorithm applies a unary function to each element in a sequence, and returns a new sequence containing transformed elements in the same order. Secondly, the filter algorithm processes a sequence linearly from the right to the left, and tests each element with a unary predicate. Lastly, the accumulate algorithm processes a sequence linearly from the right to the left, and combines each element with a binary function. Now, let's look at how the library can be applied to write incremental programs in practice. In the first demo, we have three variables, x, y, and z, where z is the sum of x and y. Initially, x is 1, y is 2. When we demand the result from variable z, it returns 3. After we update the value of x from 1 to -1, and demand the result from variable z again, we can see the returned value is now 1. This shows how incremental programs can update their outputs when the input data is modified. In the second demo, we have a sequence S1, and a predicate that returns true if the input value is greater than 1. The result sequence S2 is obtained by applying the filter algorithm with the predicate on S1. We can see that when we demand the result from S2, we get values 2 and 3. After we update the second element of S1 from 2 to 1, and demand the result from S2 again, we can see that it returns an array with one element only. In the last demo, we have another sequence with values 1, 2, 3, and 4. We want to get the smallest item in the sequence by using the accumulate algorithm. When we first demand the result, we get a return value of 1, which is indeed the smallest. After we change the third element of the original sequence from 3 to -1, and demand the result again, we get a value of -1 this time. Thanks for watching.